Little Nellie Newton hangs by a rope attached to the ceiling of an elevator. The elevator is at rest. What are the forces acting on Nellie? Did you say her weight and the tension in the supporting rope? Good, for these two forces act on Nellie. How do the magnitudes of these vectors compare? Since Nellie's in equilibrium, the sum of the forces on her equals 0. So we see T minus mg equals 0, where we see T equals mg. Nellie remains at rest because the upward tension balances her downward weight. No net force acts on her. The forces cancel to 0, yum. Easy stuff. Would the tension change if the elevator moved at constant velocity? The answer is no, for then she'd be in dynamic equilibrium. As long as the system does not undergo acceleration, the sum of the forces on the system balance to 0. That's either at rest or moving at constant velocity. Suppose the elevator accelerates upward, say with an acceleration a. How would the tension in Nellie's supporting rope compare with her weight mg? I think you can sense it will be greater, but how much greater? Sum of the forces equal ma, and we get T minus mg equals ma. We solve for T. We see that T equals mg plus ma. The quantity ma is in addition to her weight mg, the sum of which is rope tension during acceleration. How would this problem be different if Nellie were simply standing inside the accelerating elevator? Never mind the hanging rope. The answer is not all that different. For the case of standing, the support force is not tension T in a rope, but N, the normal support force by the elevator floor. Then the support force on Nellie would simply be N equals mg plus ma. Same physics, similar situation. Is this yum or what? Elevator problems were hard for me when I first encountered them as a student, but now I see them as yum. And by now, you know what I mean by yum. Intellectually tasty. Let me leave you with a question. Suppose the elevator accelerated downward with the same magnitude of acceleration a. How would the equation for support force differ from mg plus ma? Until next time, good energy.